Hello, Mr. Stone here. Today we are going to take a look at one of the niftiest things this side of Cheez-Its, the sine and cosine. Now, we have looked at tangents before. In the case of, here's my awesome right triangle. We know it's a right triangle, of course, because I'm putting a little mark down there, signifying this is 90 degrees. I'm looking at angle right here. This is theta. I know, and we've looked at this before, first of all, across from my right angle here, this is our hypotenuse, right? Hypotenuse. From here we know, going across, this is my opposite. And then that would mean this guy that's left over down here is my adjacent. And we've been able to use the fact that tangent of theta equals our opposite over our adjacent to solve a lot of problems. But what happens when we've got something like this? We've got another wonderful right triangle right here. And I know that this guy is, let's say, 7. And this one over here is, let's say this is 5. Here's my angle. Theta. Let's say I want to find theta. Well, in order to do this with tangent, we'd have to figure out what this missing side is down here, and that just is pretty messy. It takes a long time. However, I will introduce you to one of the most marvelous phrases that you will ever hear in the history of your mathematics career. So ka toa. Doesn't that just look cool? Sokatoa. Sokatoa. Say it once. No, really say it out loud. It's empowering. It makes you feel alive. Sokatoa. Now, Sokatoa. What is Sokatoa? Sokatoa is simply explaining how tangent and then two other trig relationships, sine and cosine, work. Okay, so let's break this down by letters. So S, that just stands for sine. We usually write it S-I-N, that's what it's on the calculator. It's actually sine with an E at the end. But a sine is going to be O, that stands for our opposite, like we've been looking, same way we found it when we were dealing with tangent. And the H is over hypotenuse. So if we take the sine of any angle, it's going to be equal to the opposite divided by the hypotenuse of the right triangle that it forms. Ka, the C here, is for cosine. And usually that on our calculator is just COS. COS equals, the A is for adjacent, and then the H again is over hypotenuse, adjacent divided by hypotenuse. And then TOA, well, this guy's old hat. We've looked at tangent already. Tangent is just opposite over adjacent, which we've been doing. So we know this guy. But these two new ones up here, they are kind of fresh for us. So let's see them in action. Okay. Let me do one here where we need to find a. Let's see. Let's say we've got an angle here. Let's say this angle is 60 degrees. Let's say that we know our hypotenuse here is 17. And we need to figure out this guy right here. So I take an inventory of what I've got. Oh, and this is a right triangle, of course. This is my hypotenuse, right? Because it's across from the right angle. So there's my hypotenuse. I check it out, and then hey, what do you know? My x is my opposite. So I go back up here to Sokatoa, and I see that the one that's got my opposite, which is what I've got down here, my opposite, Also has my hypotenuse. Well, that would be my sine. So I'm going to have the sine of 60 degrees equal to my opposite, which, I don't know, that's x, over the hypotenuse, which I do know is 17. So we'd solve for this just like we would solve for tangent. We need to clear out that 17 out of the denominator. These cancel. So we get 17 times the sine of 60 is going to equal x. We can do that in our calculator. Let me pull up the calculator here, okay. So, sine of 60, okay, I'm just using the sine key there, is 0.866. And then I'm going to multiply it, so I'm going to round a little bit here, of course. I'll round a point, well, let's say 0.87. Okay, so 0.87 times 17. Now I can figure out that my missing side here is going to be about 14. Let's round again to the nearest tenth. 14.8 equals x. That's it. We've solved for that missing side. We did not need to find this guy, which normally we would need to do if we were going to use tangent, and it works out pretty easy peasy. We can do the same thing with cosine, except cosine, you're just going to be using your adjacent and your hypotenuse. You don't need your opposite involved in that one at all. And just like we used inverse tangent, we can do inverse cosine and sine as well. So let's use this guy from earlier, the 5 and 7. Okay, I'm going to recopy it down here. Again, right triangle. This guy over here was 5. This guy was 7. Well, let's do this one with cosine. So let me make this my theta. Okay. So take stock of what we've got. Got a hypotenuse here. That's our 7 because that's across the right angle. My opposite I know to be over here, and I don't know my opposite. So that means this guy that's left here is going to be my adjacent. And like I just hinted at a second ago, we go back up. We have a hypotenuse and adjacent. That means that's going to be this cosine right there, because that's the one that fits. It's got our adjacent and our hypotenuse. So my cosine of theta is going to equal adjacent, which we said is 5, over hypotenuse, which is 7. And we can do inverse cosine of both sides. And this will just give us, these will cancel each other out there. So we have theta is equal to the inverse cosine of 5 over 7, which we can plug into our calculator over here. Oop. 5 divided by 7 gives us that fun guy. Really? Wow. That's neat. 5 divided by 7 is that? I haven't done that one in a while. Interesting. Alright, anyway. 5 divided by 7. And we want to find the inverse cosine. So usually that's done by doing some sort of second function right there. That mine right here is this guy. On your most of your calculators, just second cosine, and it triggers cosine to the -1, the inverse cosine. And that means that our theta there is going to be 44, around to the nearest 10.4 degrees. Isn't that cool? We can totally avoid having to use any extraneous Pythagorean theorem. I think it turns out pretty well. Anyway, that's sine and cosine. We'll be looking at this more. Review this if you need to. Think of any questions that you've got. And I think that we will be good. So enjoy and have an awesome day.